is an overwhelming task. So this is what drives the safety critical business today. So what do we have for this? We have standards. We require standards to develop a safety critical product. And what are the different standards available? You have got standards in all the domains. So you have medical field with the 62304, you have the automotive domain with the 26262, you have the railways with the 50128, and the avionics with the DO178C. So you have all the standards in place. So we have done a good job there. The DO178C standard, that is because I'm coming from a aerospace background. So this is our daily, Bible which we read every day, sort of. And this standard tells you that there are 5 basic levels of criticality, and how we have to test them based on the criticality. And recently, the new standard DO178C has a model-based supplement which talks about how do you do a testing, how do you develop a system if you have requirements given as models. So this standard has realized that going forward, model-based is the way to do things. To start any activity, we require to have a safety analysis. So this picture basically tells you how the different standards are related. So you start with the safety of a system, and then you have the other standard correlating. So this is basically for an aerospace domain. So initially, we start everything with a system level safety assessment. So remember that there is a big difference between safety and reliability. A highly reliable boiler which can withstand 2 times the pressure may explode with twice the force in an unsafe condition. So you have to remember this specific aspect. Safety is different, reliability is entirely different. The software will perform very well as it has been designed and tested for this. It will very faithfully carry out the function defined by the requirement. So we have to ensure that the requirement is safe under all conditions. So requirement is what drives your safety. These are basically the criticality levels in the DO178C. So you have the software criticality, catastrophic, these are talking about the accidents. And what should be the probability of failure? So 10 power minus 9 failures in 1 hour of operation is a software with catastrophic criticality. So this is what should happen. And 10 power minus 9 is a very small number in 1 hour of your flight or 1 hour of operation. And that is designated as a level A for a DO178C. And 178C lays down certain objectives. So it says that you have to fulfill these objectives to come up with a better system. So one of the objectives could be low-level requirements have to comply with high-level requirements. So things like that. So there are a set of objectives which are there categorized over different product life cycle. So in the life cycle phases. So you have planning, you have development, verification. So if you see here, planning and development has 7 each, whereas verification has 43 for a level A in a DO178C. And there is something called as independence there. So you have, if you see for a level A, 25 objectives have to be looked at with independence. So what does you mean? What do you mean by independence? Independence means that if I am doing the piece of code, if I am writing the requirement or I am writing a piece of code, then there should be somebody else who has to review it and ensure that what I have done is correct. So that is independence. The essence of DO178C is that every line of compiled code is directly traceable to a requirement and a test routine. So it should be traceable both to a requirement and a test routine, and there is no extraneous, or outside code, and the proof of this should be generated on the actual system that flies. So that is very important. Where you test it on the actual system that flies. That was about the DO178C requirement for the standard for the aerospace. In the automotive domain, you have the ISO 26262. And a beautiful comparison is given in this particular paper. It's available in Google. If you search for it, you'll get that. A very well written paper which says, can cars fly? Okay, and actually they can. So there is a car which can actually fly. It is half aeroplane and half car. But the standard is pretty much applicable. Now, in DO178C, you saw a lot of levels. So even in 26262 for the automotive, you have different levels, which are, I think, classified in a better fashion than 178C, because you have classes for severity of an issue, you have classes of probability, and then controllability. This controllability is not there in the 178C. And based on these things, you define your levels. So you define the SL levels based on the probability of occurrence, the severity of the accident, and so that is how the level D is the most catastrophic, which is level A in 178C is level D here. And if you see 26262 recommends different ways of testing, which is not available in the 178C. 178C doesn't say how you go about testing it, whereas 262 says how to test it. And there is a back-to-back test where the responses of a test object are compared with a simulation model. So it is basically talking about a model-based test here. When you do a comparison between, you will see that there are a lot of commonalities. One thing is the modified and decision coverage. This is basically talking about a code coverage where both the standards talk about the same thing. And it is mandatory for level A, and it is also mandatory for the 26262. The other standards are the 61508 for the industry. Again, you have the same gradations here. What is acceptable, what is the probability of failure. So everything is on the same lines. And you again have the 10 power minus 9, 10 power minus 6 numbers, which are there in DO178C. So the numbers are also pretty much the same. Similar, and again, in this case, there are only 3 classes of criticality, which go from A to C. C has the highest criticality. And again, you have different levels based for the medical also. So coming to the whole thing, what I summarize this is that there are many religions and doctrines in the world today, and they all talk about the same thing, right? Be, go, do this and all that. Similarly, all our safety standards, they are talking about the safety levels and what you better do about it. So this is all the standards talk about. So it doesn't matter which standard you are referring to, it is one and the same. And the source of all development is requirement. Treat it like a Bible or whatever your religion is. Treat it with the document or a book for your religion and preach it to everybody who is involved in the project. So this is very, very important. What we have seen is most of the time errors happen because of requirements rather than anything else. So I'll just cover a bit of mistakes that we have made. These are what you can see here is the recalls attributed to software failure, and the very recent data for the medical field. So you have a 20